Alright, in lesson 2.8 we're going to be graphing tangents, cotangents, secants, and cosecants. But first let's review our cosine and sine graphs. So if you want to pause the video and get these graphs down, we're looking at here cosine, and we've got our critical numbers 0, pi over 2, pi, 3 pi over 2, and 2 pi, which are just the quadrant boundaries, the x and y axis around the unit circle. And then we've got our regular cosine values where cosine starts at 1 and then goes to 0, -1, 0, and then back up to 1. Sine has the same critical numbers, 0, pi over 2, pi, 3 pi over 2, and 2 pi, which are your radians around the unit circle. And then you're going to see for the sine values, you have 0 first, then 1, 0, -1, 0. So we keep those in mind because we use cosine and sine graphs to make the other 4 trig functions. So let's start with creating a tangent graph. What we need to remember is that tangent is sine divided by cosine. And whenever we are making a graph, we can never let the bottom equal 0. Because if the bottom equals 0, then your function is undefined. So sine on top is fine. That doesn't give us any problems. But cosine being in the denominator, sometimes cosine is 0, and that's going to create an undefined part of the graph for tangent. So because cosine is giving us a problem in the denominator, that's how we're going to start this tangent graph. We are going to graph cosine first, and then we're going to see where cosine hits 0, because that's where tangent is going to be undefined. So let's graph cosine. We've got 0, pi over 2, pi, 3 pi over 2, 2 pi. And it goes up 1 and down 1. And then cosine starts at the high point. So at 0, we're at 1. And then 0, -1, 0, 1. And I'm going to make a dotted curve because I don't really want cosine, I want tangent. Cosine's just going to help me get there. So dotted curve because that's not really the graph, it's just helping me. Now anywhere where cosine crosses the x-axis, that means the cosine is 0 there. It has a y value of 0. And that makes tangent undefined, which means there's an asymptote there. So I have a vertical asymptote at pi over 2 and a vertical asymptote at 3 pi over 2, because that is where cosine is 0 and cosine's in the bottom. So now that we have asymptotes, tangent is always going to cross in the middle on the sinusoidal axis. So between the two asymptotes, that means it's crossing at pi on the x-axis. And tangent curves up to the right towards the asymptote, and it curves down towards the left towards the asymptote. And then we can do that on all sides of the asymptotes. So that means if I have an asymptote at 3 pi over 2, the next point is going to be 2 pi. It's going to cross on the sinusoidal axis, and it's going to curve up and down. It's also going to cross at 0, up towards this asymptote, and then down towards the one over here. And so that is your tangent graph. The actual part of the graph is the solid line. So this is the tangent. All the dotted lines are just kind of a guide to create the tangent. So now let's look at your cotangent graph. Cotangent is just tangent upside down. So that would be cosine divided by sine. Now sine's on the bottom, and we can't let the denominator equal 0. So we're going to figure out where is sine 0. So that means we're going to draw a sine graph first. So let's draw a dotted sine graph. So those are my critical numbers. It goes up 1, down 1. And sine always starts at the origin. So we're going to have 0, 1, 0, -1, 0. And then anywhere where the sine graph crosses the x-axis, I'm going to draw a vertical asymptote. That is where the cotangent graph will be undefined, because we're going to have 0 in the denominator. So I draw in my asymptotes at 0, pi, and 2 pi. And then cotangent looks very similar to tangent, it just curves in a different direction. So we cross in the middle between the two asymptotes, which means at pi over 2, we're on the x-axis, but it curves down to the right and up to the left. So we're going to cross in the middle at 3 pi over 2 between the two asymptotes, and we're going to curve down to the right, up to the left. So this is my cotangent graph. These solid curves is your cotangent. For secant, we are looking at 1 over cosine, and we can't let the cosine equal 0. So that means we're going to graph a cosine graph and find our asymptotes. So 0, pi over 2, pi, 3 pi over 2, 2 pi. We go up 1, down 1. Cosine starts at the top point, so 0 is at 1. Pi over 2 is at 0. Pi is at -1. 3 pi over 2 is 0. 2 pi is back at 1. And we're going to make a dotted curve because we don't really want cosine, we want secant. Anywhere where cosine hits the x-axis is where the cosine value would be 0. So we draw vertical asymptotes through those 2 points, which is at pi over 2 and 3 pi over 2. And then secant is different looking from tangent and cotangent. Secant is going to share the same high points as the cosine, but it's going to curve away from all your dotted lines. So it looks like that. And then it shares the same low point, so it's going to touch at pi at -1, and it's going to curve down. And then up here at 1, it's going to share that point, but it is going to curve up away from your dotted line. So the secant graph are these curves up here. Let's look at cosecant. Cosecant is 1 over sine. So we can't let sine equal 0. So we're going to graph the sine wave. 0, pi over 2, pi, 3 pi over 2, 2 pi. Sine goes up 1, down 1. Sine starts in the middle at 0. So 0, 1, 0, -1, 0. And we draw this dotted curve. And I draw my asymptotes at 0, at pi, and at 2 pi. And then cosecant looks very similar to secant, where you're going to share the same high point. So at pi over 2, we have a point at 1, and it curves away from the dotted line. From the dotted curve, it's the opposite. And then 3 pi over 2, we have a point at -1, and it curves down away from your dotted lines. So this is my cosecant graph. Last thing I want to talk about on these is your domains and ranges. So let's look at tangent. Tangent, my domain is not -infinity to infinity anymore because of all these asymptotes in the graph. So we've got what we'll say is the domain is all real numbers. We're going to use the all real number symbol now, except, and then we list our asymptotes. So we have a curve everywhere on the x except for when x is pi over 2, 3 pi over 2, and so on, because we're going to have more. The range, we see that it's a smooth curve going down to up. So starting at 0 it goes all the way down with an arrow, and starting at 0 it goes all the way up with an arrow. There's no stops along the way. So my range is -infinity to infinity. So same thing for cotangent. We've got a weird domain because there's all these breaks in the x-axis. So we're going to say it's all real numbers except When x equals 0, we've got an asymptote. Pi, we've got an asymptote. And 2 pi, we've got an asymptote. And we'll put comma dot 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 because this will keep on going. And then the range is negative infinity to infinity because it's a smooth curve going up and going down. It doesn't stop. Secant, the domain, is all real numbers except when x is, here I've got asymptotes at pi over 2 and 3 pi over 2. So we list those and then we put dot 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 because there's going to be more that are off the graph. And then range, this one has a low part to the graph and a high part to the graph, but there's nothing in the middle, so we have to write that for our range. So we start with our smallest y value. Since there's arrows that go down, that means the smallest y value is negative infinity. Then in that section of the graph, the highest part of this bottom section is negative 1, so it goes up to negative 1. And I put a bracket on negative 1 because it actually has a point at negative 1. It touches that y value. But I put parentheses on negative infinity because you can never actually touch infinity. It'll just get smaller. Then we put a union symbol, which means your range is this and whatever I'm about to say next. And I've got this top section. So I'm going to talk about the top y values. So the lowest y value on top is positive 1. And we actually touch there, so bracket on it. And then there's arrows going up, so comma infinity. It goes to infinity. Cosecant, I've got domain is weird again, all real numbers, except when x is 0, pi over 2, and, oh, not pi over 2, 0, pi, and 2 pi, where your asymptotes are. And then your range is negative infinity to negative 1, bracket on the negative 1, and then 1 to infinity, bracket on the 1.